In our last lesson, we looked at some basic shapes of, looked at the shapes of some basic graphs. And what we're going to learn about in this lesson is if we have a function that starts out as one of those basic functions and then has some numbers added or subtracted. In our lesson after that, we'll look at what if we put a negative or if we multiply. It's going to move the graph. The basic shape will stay similar, but it's going to move the graph around on the coordinate system according to some rules. So the first thing I want you to do is I want you to see if you can recreate from memory or by looking back in your notes the basic graphs. Y equals x, y equals the absolute value of x, y equals x squared, y equals the square root of x, y equals x cubed, and y equals the cube root of x. These are the ones that we're going to primarily practice with at this point. And then at the end of the lesson, we'll talk some more about that these rules work regardless of what your basic function is. So what I want you to do is from memory, I want you to try to recreate, and I'll do the linear one here. I want you to try to recreate each of your basic graphs. And I do want you to go ahead and plot 3 actual points on the graph. And notice if x equals 0, y equals 0, if x equals 1, y equals 1, and if x equals negative 1, y equals negative 1. So go ahead and plot x equals negative 1, x equals 0, and x equals 1 on each one of your graphs. Pause the video, create those graphs for each function, and then turn the video back on. All right, let's see. Hopefully you've already done these on your own. Absolute value of x, we have 0, 0, 1, 1, and negative 1, 1. And we know our basic shape looks like this. On x squared, we have the exact same 3 ordered pairs. But we know that our basic shape is a parabola. So 0 squared is 0, 1 squared is 1, negative 1 is 1. So we have the same 3 ordered pairs we had on the absolute value, but we have to memorize or know that we have a nice curved parabolic shape. And then on the square root, we have 0, 0. The square root of 0 is 0. The square root of 1 is 1. And we cannot do the square root of negative 1 in the real number world, which is what we're in when we're doing graphs. So we don't have that point over there on the left, and we know from memory that our shape looks like this. For x cubed, the cube, x 0 cubed is 0, 1 cubed is 1, and negative 1 cubed is negative 1. And that's the same 3 points we got on the linear function. But we know from memory that our basic shape curves up like that and down like that. And then on the cube root, the cube root of 0 is 0. The cube root of 1 is 1. And the cube root of negative 1 is negative 1. And again, we get those same 3 points. But we know from memory the basic shape of a cube root looks like this. So those 3 ordered pairs are not enough to actually create the shape. You have to know that basic shape. And I'm going to change this one. It's not curvy enough. It should be a nice curve. So we know the basic shape of each of those graphs. Now we're going to use those and the ordered pairs that we plotted to do our transformations. Our first transformation rule that we're going to look at is if we have some function, g of x, which was some known function, f of x, plus some number. We're going to see that what that does is you plot all of your points, but then each one of them moves up c units because the plus c is outside of the basic function f of x. Leave some space here because we're going to come back and put more transformation rules. But first we'll look at an example of this. For instance, let's say that I have a function, g of x is equal to x squared plus 3. My basic function is x squared. And then I'm adding 3 units. So that tells me that my entire function moves up 3 units. So my process here is to graph my basic function, list my transformations, and then graph the original given function, in this case g of x. This is where knowing your basic functions and being able to quickly and easily graph those is going to be useful. So my first step is to graph y equals x squared. Go ahead and do that, plotting those 3 points, and x equals -1, 0, and 1, as we did a few minutes ago. Then list your transformation, and then move each of those 3 ordered pairs up 3 units, and then draw your new graph. You see if you can do that, and then I'll do it. All right, y equals x squared is our basic graph, so we plot our 3 ordered pairs. And we know that it's a nice parabolic shape. And I find most of these graphs easier to do if I go from 0, 0 to the right and to the left rather than trying to draw it all at once. So this is my basic graph, y equals x squared. Then my transformations in this case, I have a plus 3 outside of the function, so that will be up 3 units. So that means that I'm going to move each of these 3 ordered pairs up 3 units. So this one comes up to here. This one moves up to 1, 4, and this one moves up to -1, 4. And then I can just recreate my parabolic shape, my x squared shape, using those 3 ordered pairs. And I have my graph g of x equals x squared plus 3. We're going to use this method of graphing with transformations the rest of the semester. Think about or graph your basic function, list your transformations, and we'll see in a little bit that you can have more than one, and then graph your new function g of x. Let's look at another example. On this one, we're going to use our next transformation rule, and that's if instead of my given function being some known function plus a number, we have minus a number. And we're going to see that every one of my y values will go down c units. Let's look at an example of that one. Let's say we have g of x equals the cube root of x minus 4. What I want you to do is graph the basic graph, write what the basic graph is and then graph it, list your transformation, be specific about direction and units, and then move those 3 ordered pairs and graph the given function. So pause your video, see if you can do that yourself, and then come back and check. All right, looking at g of x, we have the cube root of x. So that's going to be our basic function, the cube root of x. And from memory, we know that the cube root of x has 0, 0. Cube root of 1 is 1. Cube root of negative 1 is negative 1. And it's the one that's curving to the side that way and then back to the side that way. Then we list our transformations. We have a minus 4 outside of the cube root. It is not being affected by the cube root. That means it's a change in the y direction. So it is going down 4 units. And then we can move each of these 3 ordered pairs down 4 units. So 0, 0 moves down to 0, negative 5. 1, 1 moves down to 1, negative 4. Oh, I'm moving things 5 units here. Let me fix that. All right. So 0, 0 moves down 4 units to negative 4. 1, 1 moves down 4 units. And then this point moves down 4 units. That's right, smack on top of my number here, negative 5. All right. So then we have these 3 ordered pairs, and we know that we're creating this same basic shape. So at that point, I can just start here at this point, the 0, 1, and recreate that same basic shape, and I have my function g of x. And this one was y. All right. Both of these were in the y direction. They were outside of the function. They were up and down in the y direction. Y is what changed. Our next 2 graphs, our next 2 transformations are going to be what happens if the x is changing. If we change the x, what does that do to the graph? And we're going to see that these move in the opposite direction of the sign given. And I'm going to explain why. I'm going to do this with some points and do some plotting so you can understand the rule. But then from now on, we're just going to remember the rule. So let's say that we have a function, g of x equals the absolute value of x plus 2. This is a change of plus 2 inside of my absolute value function. So let's go ahead and graph my basic function. In this case, y equals absolute value of x. And I'm going to do that plotting those three ordered pairs. And I'm going to make this a little larger so we can see what's going on. So we have 0, 0. This is my basic function, y equals x, 1, 1, and negative 1, 1. So this is my basic function, y equals absolute value of x. Okay, let's go ahead and plot some points and just get an idea of what is happening with this graph by making a t-table. And again, we're not going to be doing this in the future. We're just going to use our transformation rule. I'm doing it this one time to help you understand why the rule works the way it does. So I'm just going to put in negative 4 and negative 2 and 0 and 2. And if I plug in negative 4 plus 2, absolute value of negative 4 plus 2 is negative 2. Absolute value of negative 2 is 2. Negative 2 plus 2 is 0. Absolute value of 0 is 0. Absolute value of 0 plus 2 is 2. And the absolute value of 2 plus 2 is 4. So if I plot those points, each one of those points, negative 4, 2, negative 2, 0, 0, 2, and 2, 4. We see that this ordered pair on our basic graph, 0, 0, I'm thinking about what value of x would keep y at 0. And it turns out that value of x is negative 2. So that point actually moved to the left 2 units. And each one of our other ordered pairs moved to the left 2 units. Because the change is on the x, the graph moves the opposite direction of the sign. So when we are inside of the function, we are making a change in the x direction, and it is opposite the sign. So this one would be a shift left c units, and this would be a shift right c units. All right, let's go ahead and do an example. Another example where we just use our change inside the function and we go left or right. And then we'll look at one where we do both. We do a vertical shift and a horizontal shift. So I want you to see if you can do this one yourself. I want you to graph f of x equals x minus 5 all cubed. So my first step is to list the basic graph, or identify the basic graph, and graph it. List transformations. And then move those ordered pairs and graph the new graph. So pause your video, see if you can do those 3 steps. Alrighty, so let's see. Because we have this cube here, that means our basic graph is y equals x cubed. I graph that graph. I'm going to go ahead and move down here and graph it so I have plenty of room. 0, 0. 1 cubed is 1. Negative 1 cubed is negative 1. And I know my basic graph is the one that goes upwards, just like the parabola. X squared goes upwards, x cubed goes upwards, but because a negative cubed is negative, this side goes down. So this is my basic graph, y equals x cubed. Now I list my transformations. I have a minus 5 inside of the parentheses here, inside of the function. So that means that I go right 5 units. And then I can take each of these ordered pairs, move it to the right 5 units. And then I recreate my basic shape, starting with this one, curving upwards, and taking this one and curving downwards. And that is my function f of x. Okay, let's try one now where we have more than one transformation. Let's say that we have the function y equals, and I'm trying to use, I don't know if you're noticing here, I'm using g of x, f of x, y. It doesn't really matter what we call the function, our process will be the same in each case. So let's say that we have y equals the square root of x. Minus 2 minus 3. We're going to do this the exact same way that we did our process before, which was to graph the basic function, list transformations, and then graph our new function y by moving those ordered pairs. And we're going to see on this one that we have 2 transformations, and we're going to do each one separately. And we're going to move from left to right as we do that. So I want you to see if you can do the first 2 steps. Identify your basic graph, graph it, plotting a couple of points, then list your transformations. And I'll give you a hint on this one. We have 2 separate transformations, so list each one separately. And then we'll look at graphing my original function. Pause the video, try that, and then check back. All right, because I have a square root, my basic function is y equals the square root of x. So I plot that on my coordinate system. 0, 0, 1, 1. I don't have a negative 1 because you can't take the square root of a negative number in the real number world. And I draw my basic graph. Then we list our transformations. And we're going to see that the first transformation here is a minus 2 inside the function, inside of the square root, so that is right 2. And then we have the transformation minus 3 outside of the square root, so that's going to be in the y direction, down 3. And now I can do each of those transformations separately. And I'm going to draw actually 2 separate graphs. The one in the middle will not be the final graph. It's just going to be an intermediate step. I'm going to do the right 2 first. So I'm going to take each of these points and move them 2 units to the right. And that's my minus 2 inside the radical, my right 2, and I redraw my shape. And I'm just going to draw it as a dashed line here because that's not our final graph. That's just the one with the -2. And now I can take that red one and I can move each point down 3 units to do the -3 outside. So this ordered pair moves down 3 units. This ordered pair moves down 3 units. And I can recreate my basic shape. If you want to do both shifts at once, you could go over 2 and then down 3, over 2 and then down 3. But while you're practicing, you might find it easier to go ahead and draw that intermediate one. And so this graph is my y equals the square root of x minus 2 minus 3. The main thing to remember on these is to write each of your transformations separately and then do that transformation separately. In our next video, we're going to look at several more rules on how functions can be changed by putting in a negative or by multiplying by a number.